And now the unit number 2, support reactions. So any body which is under equilibrium, to keep it in equilibrium you need a different a solution for the equilibrium reactions, for which horizontal, that is sigma h, and vertical sigma v, and for the resultant it is in square root of sigma h square plus sigma v square. That's what we have seen. But the next step, when you go for something called solving the reactions, you need some kind of supports that are based on the structure of the body. So for example, you have been seen in many structures, that is, to make up a building, instead of going for a roof structure, that means concrete structure, you can even make it with some kind of sheets, say asbestos sheets. Before that, they'll go for some kind of arrangements, which means something called welded rods, I can say. The structure will be like this. Simply, in this fashion, you will have lot of supports for this total roof, and the bottom will be like this with your columns. Right? I am talking about any building which is just been made up of a sheet. The roof is made up of a sheet or asbestos, like that. For that, to take the load of that particular body, you will have some kind of supports. Those are called, actually, you can call it as frames. Frames, okay? Or you can call it as, it's called welded joints. Either it can be welded joint or it can be frames, and technically this is called as truss. The name is called truss, which means by joining different bodies with the different the weight or size of the body, you can have number of joints, say 1, 2, 3, etc., n number of joints. This will give a support for the roof. The roof may be made of anything. Maybe it's a sheet, zinc sheet, or asbestos, etc. So we are just studying about these support reactions. What kind of loads are applied for a body when you need to go for some kind of welded joints or frames, right? So in general, there are 3 types of support reactions can be possible. That is divided into 3 types. The first thing is called a roller support. The second one is called hinged or pinned, P-I-N-N-E-D, pinned support. And the third one is called fixed support. So there are different kinds of support reactions. In this, basically these 3 come into picture when you study about any structure. For example, a roller support is the one which will normally have a single reaction only. In the sense, if this is my body, this roller support can withstand only the vertical direction alone. What I mean to say, if there is a load applied for this body, this roller support will always be at 90 degrees exactly to that plane, which means you will have just consider into 3 planes, say your x, y, and z. Whatever the plane you consider for a body, this roller support will be giving a reaction only to the perpendicular line of that plane. You may take it as of xy plane or yz plane or zx, whatever it is. But the roller support will only support in the direction vertical to the plane. This is by roller supports, which means if there is any reaction or any force is applied to the horizontal direction, the support will fail. Right? So if this is a load, say suppose W, some Newton it is, 10 Newton or 100 Newton, this roller support can resist or react or support only in vertical direction. Once in the horizontal direction, get failed. Because the setup of the support is, in the nature is that it will withstand only the vertical load. If the load is horizontal, suppose this is the body, I am applying a load, say suppose 10 Newton is on pressing, this roller support can adjust or give a resistance only from vertical direction. When there is any force acting on the horizontal side, obviously gets failed. Right? So that's called your roller support. So this is basically supports only the vertical reactions, I can say. Right? So under support reactions you have, there are a number of different parts, but still these 3 play an important role. with which we can decide what type of load is that. Basically, roller support is the first one, which can withstand only the vertical direction. Or I can say, you consider any plane of x, y, y, z, zx, the body may get a load, or load may be applied in xy plane, or yz plane, or zx plane. But anywhere it is applied, this roller support can give a reaction or give a resistance only at vertical directions. Say for example, I'll just keep this particular body in this direction. It's inclined now, but still the load is considered exactly, perpendicular, 90 degrees. This was your roller support, right? So roller support is only for the vertical reactions. And when you come for this hinged support, hinged or pinned, it's called a hinge or pin. This hinge is a simple example of your door. You have door and windows in the house. When you open a door, what will happen? The corners, we have 3 or 4 hinges. The hinges are meant to take a reaction of either vertical or horizontal. Actually, to see when you open a door, it swings off, right? When it swings off, it will take both the vertical loads as well as horizontal loads. So this hinge support can take up both your vertical as well as horizontal loads. A roller can take only the vertical load or resist the vertical load, and hinges or pinned support can take both the horizontal and vertical loads. And third one is your fixed support. In general, any body will be subjected to 3 kind of reactions. One may be in horizontal, other may be in a vertical. The third one, a twisting is possible. Why? Because if I want to just apply a load on this duster, when I hold it in 2 sides and try to break it, I may be applying a load on horizontal side or vertical side, lateral and longitudinal, but still when I twist it to break it, you will have the rotation load also, which means it gives a twisting movement for the body, so it gets faked. So that twisting movement or a rotational load, in terms of load as big as a rotational load, can also be taken up by a support called a fixed support. That I can say in terms of this. Again, I'm just showing you structure of a body, right? So this will have some loads. I can say a vertical support will be given by your roller support, 90 degree apart. Normal it is. And horizontal by the hinge support. What about the twisting movement is a question, because the loads will not always be either vertical or horizontal. It may be in inclined direction also. What we do in inclined directions, generally we go for your x and y plane, as we did in previous chapters. When the load is inclined, we will go for solution of this dissolving. You will convert it into one vertical and one horizontal directions. I hope you remember it. So that way, this fixed support will take up any inclined load which will tend the body or move the body and give a rotation, so that the twist will be, a jerk will be there. For example, you can, a practical example is if we have a big companies, when you want to move a body from one area to other area, they used to use the cranes. Now the crane is a normal word, you can understand, which will take up the load. What it does, a person will be operating in some other corner. He'll put on the switches. The crane will be moving from either to and fro directions. When a person in the ground, when fix up the hook in the particular box, which will be moved from one place to other place, that will start jerking from one place and keep on rolling to other place. They'll fix up a kind of wheels there. For that I can say they'll be using a diagram like this, which shows number of rolls. This rolls indicates that a body can be just moved or rolled from one place to other place. Meaning is below this, in the third direction, you will have some body to be supported. It will be just pulling off or holding it in a different height, and it will move from one point to other point. Here you require, first thing is the vertical total load, because the first thing is the self load of the body itself. I mean to say the crane itself. The second thing is the load which is in the bottom. Some box it is. Say some box with some materials to be carried out. The third one, when it rolls, these wheels will keep on rolling in this total, it's called conveyor. It conveys from one place to other place. So all these supports will have to carry from one end to other end based on either it is a roller support or hinge or pin or fixed supports. So the support reactions is the one which we have to understand, analyze and study, because any body is subjected to some kind of load will have to come for an equilibrium only by understanding its horizontal vertical reactions as well as the rotational load also, right? So that is the idea of studying your support reactions. So under the support reactions, you will have to just learn one or two problems to understand how does the moment gets changed. Moment is nothing but, I told you, force into perpendicular distance. I repeat again, it is force into perpendicular distance, not merely a distance at all, because the moment is applicable in either of the body. Anywhere a load is applied, moment will come into picture. That moment is nothing but a load applied into perpendicular distance. If there is no distance, it becomes zero, right? So all this, your fixed support, your hinged support, or roller support, whatever it is, all here in this, when a load is applied in a body, say for example a frame I will consider. This is just a beam or a frame. Or here I'll take 2 points A and B, right? So one end of this beam may be fixed to a corner. In the sense it's fixed in one area. The other end will be flexible. For example, if some weight of some Newton, say 10 Newton is applied to this body, how do we calculate this body's reactions at point B? Which mean to say, if this tosser is a frame or a beam, when I apply a load in one corner, it starts slowly bending. Okay, which means I am giving an example of holding in one point, say suppose point A, and point B subjected to a load. What will happen here? It starts bending like this. What will happen? It goes to the maximum extent, and when the other end is rigid, very rigid, holding it tight, it starts slowly failing. It starts breaking. So this maximum load and its reaction is to be studied under the support reactions. So one or two problems, when we solve it, you will understand the purpose of studying the support reactions under your either roller support or your fixed support or hinged support, right? So don't forget, roller means which takes only the vertical load. Your fixed or hinged, fixing or hinge. Hinge is, I told example of a door and window. That will take up your vertical load as well as the horizontal load, right? And the third one comes your fixed support, which will take the three loads. One is vertical, the horizontal, as well as the twist load. I can say it's not twist, it's rotational load. So only three loads are basically possible when a load is applied to a body, which to be, for that you need a resistance to keep the body in equilibrium. The ultimate aim of studying mechanics is that we are finding out how to keep a body in equilibrium condition, right? So we'll just go for one or two problems, will be more easy to understand. Okay. So before going for the problem, we'll just see a difference between your the comparison between roller and hinge support. So basically the diagram is like this. Your roller means you will have single reactions in vertical side. Okay, you'll write RV, roller support, vertical direction. If the body is changed also, that means if you have a tilting of the shape also, this roller will have only the vertical direction. Now it just kept in this direction. If you tilt it to any angle also, the reaction for this roller will be only vertical direction. This is what the sketch shows. This is when the load is directly vertical. When you have a load of inclined load, suppose your load is P, okay, and its inclination is theta, here it is given sketch. So this is roller support, and this your second unit is your hinged support. Okay, second is hinged support. Here you will have, as I told you, one vertical and horizontal reactions. The vertical reaction is taken as P into sine theta. Why? This P is what? Your load, applied load, and sine theta is why? We know that when the load is inclined, right, what will you do? You will have two directions as in the previous one. This becomes cos theta, this is sine theta. Is it not? So first unit we have learned is, we have just taken an inclined load is converted into two components. One is vertical and horizontal. The horizontal is taken as cos theta, that you know how it has come, and vertical is as sine theta. So the vertical is P into sine theta. P is applied load into angle is sine theta, right? Because this inclined load converted into one vertical, one horizontal. That's what the meaning is. And the horizontal will be P cos theta, right? Now when you come for the third one, this is your inclined load. Inclined load in the sense this is fixed support. First one is roller, second one is hinge, third one is fixed support. In the fixed support itself, you will have two kinds of loads applied. If the load applied is only vertical alone, you will have one thing is this P, applied load is P, the reaction will be R1 is equal to P, because vertically applied load is P, it's P. And fixed support means, I told you, it will take up the rotational load. The rotational load is given in the direction of this arrow mark. It shows it is a moment. Rotation means it gives a moment. Moment is this force applied into distance, perpendicular distance. Force applied is what? P. Distance is A. Applied force is P, into distance is A. So load into P into perpendicular distance, it is P into A. That's where reaction R2. R1 is P, because directly vertical load, vertical reaction, R1 is equal to P. And horizontal is, it's not horizontal actually, it's your rotational load. It is taken as applied load P into the distance of this point, that is A. So moment is force into perpendicular distance. So distance is P, the distance is A, and load is P. So that is what R2 is equal to P into A. This is when, for a fixed load, when the load is taken as vertical, single point vertical load only. But when the load is inclined again, what will happen here? Any inclined body will be converted, force is converted into two of its components, one horizontal and vertical like this, as well as you will have the third one as same twisting or rotational load. So what will happen here? R1 is P sin theta as it is. This is converted into, this is arrow mark like this. You will convert one vertical, one horizontal, right? So vertical is taken as R1 P sin theta. P is applied load, sin theta is for vertical direction. That you have already done in the unit number 1. And P cos theta is for horizontal load. And the third one, your rotation is taken as P sin theta into A. Why is that so? We need a load in vertical direction into perpendicular distance. Because for the horizontal reaction, though it is R2 P cos theta, this cannot be multiplied with this distance, because this load applied into perpendicular distance, which is what we want. But what about this one here? The A is this direction, this distance. The load applied is horizontal. Both will get the same line of action. For there is no moment there. The moment is only for the applied load into perpendicular distance. Clear? So it is here, R1 is P sin theta, R2 is P cos theta, and third is what? Your rotational load. That is P sin theta into this perpendicular distance A. So this is how you take 3 load roller, your roller, hinged and fixed support. Now just a comparison between your roller and hinged alone, just to know what is it. Roller is nothing but a simple vertical reaction alone is possible, which can withstand only the vertical load, so it is roller. Now when you come for hinged is means if the load applied is inclined, you will have an angle there theta. It is converted into one horizontal component and vertical component, which means you have a inclined reaction there. When you have inclined only, you are converting, this is inclined load. So converting into load at resistance at horizontal side and resistance at vertical side. So your resultant will be root of R at horizontal, resistance at horizontal whole square plus vertical whole square, and its angle theta is connected by tan inverse of RV by, that is resistance vertical by resistance horizontal. It's the same thing what we did for sigma h and sigma v, and theta is equal to tan inverse of sigma v by sigma h. Same purposes. So with these formulas, you are going to solve a question, a problem. So if you solve 1 or 2 problems, you will come to understand what is actually we are finding out to keep the body in equilibrium, right? Now, here's one. It's a problem, an example. To find the support reactions of a simply supported beam. Simply supported beam. So basically, a simply supported beam means a beam which will have direct or 1 or 2 point loads alone, right? So here in this sketch, you can see that there are, this beam contains of 2 ends, that is A and B. At end A, with this diagram indication, we have to find out what type of reaction is this, support is this. What support is this? It's a roller support. So this sketch indicates if there is a roller like this, it's a roller support. And this one, without the roller, with this kind of marking, it indicates a hinged support. So it's very important to identify what type of support is that. Only then we can write down what is the reaction. How many types of reactions? That depends on what type of the sketch is that. I mean, what type of support is that. So here it is a roller support. This is the hinge support. The roller support will have only a vertical, say, direction, reaction. I'll write, since it is point A, reaction at A. See, the question is given as such. So the first step of this problem is you have to just convert or write another diagram, equal diagram. It is you have to write equal diagram and indicate what type of reactions are available. So the first reaction I am indicating is RA, that is reaction at point A. So anything we have for horizontal direction here? No, because since it is a roller support, we will have only a vertical direction load. Reaction alone for this support, roller support alone. So RA. Here when you come here, this what support is this? I can write here, this is roller. Here it is hinged. This is for your identification. You need not write it here in the examination. Just to know, understand this hinge support. So this is the hinged means you will have two types of reactions. One vertical and horizontal. That's very important to understand. Roller will have only one reaction vertical. Hinge will have both horizontal and vertical. Now first you write the vertical reaction. Write RB. That is reaction for this hinge support at vertical side is R reaction B. Now for the horizontal load to write, usually we will write horizontal in, you can write in either, you can ask me the question is the reaction should be in either direction. You can write either in towards the point B or away from the point B. You take an assumption, assume that always the support is given outward from the point of application, which means at this point you consider when this is an hinged load, a load is applied, the horizontal reaction is taken, this H horizontal at point B is taken in terms only of resistance given or a reaction given from point to outwards, right? Say for example, after finding the answer, when you will see the purpose of this problem is to solve it, what is a reaction RA you have to find out, what is RB you have to find out, and what is HB. So instead of writing R, I'll write V, vertical at point A, vertical at point B, and this is horizontal at point B. No, it is horizontal reaction. The horizontal reaction at point B, when this answer comes a negative value, okay, see we have just this vertical given arrow mark up, it is known that a load is applied, this vertical will be always perpendicular to applied load, so you can take it as VB or VA, no problem. But when it comes to the horizontal reaction, you can either take it as an arrow mark towards the point, towards the load, or away from the load. That is very important. But what I am suggesting, this assumption should be made so that we assume that the reaction is taken from outward from the body, outwards the body. So basically you take it as HB here and out of the body, it's going out of the body, right? But when you find out the answer of this HB, if the answer is negative value, you have to change the direction. At the end, after finding the answer, you have to write again a sketch and show this arrow mark in the opposite direction. But when the answer is positive, you can leave it as it is. What I mean to say, if the arrow mark which should be always taken out of the body, outwards the body, when the answer is positive, you can leave it as it is. But when the answer comes negative, you should change this arrow marks, nature of arrow mark, direction in the opposite. So let it be as it is as of this problem. So any problem considered, first we have to write what are all the reactions. So reactions for roller will always be only one reaction in the vertical direction. Point A is here, so vertical reaction point A. Here it is vertical for point B. Since it is a support of a hinged or twin support, you will have one more horizontal reaction also, which is taken at outside the body. It's considered to be acting outward the body. Okay. Now to find out the answers. How do you find out? Basically we go for finding out sigma h, which means summation of all the horizontal loads. Right? Now here, how to write? What are the horizontal forces here? Here is an horizontal force, which implies HB is your horizontal direction, which is equal to 0, because there is no value. There is no loads at all. Horizontal direction, there is no loads. Everything is vertical. So the reaction is vertical, the load applied is vertical. So I'll write horizontal to find out the equilibrium, you will go for sigma h, sigma v and resultant. Sorry, as well as moment also here. Now sigma h is equal to, you are finding out horizontal, HB becomes 0 because there is no horizontal reaction in loads also. Now when you go for vertical one, sigma v, what are the loads here? Given 4 kilonewton, or before that VA is acting upwards. We know that any force acting upwards taken as positive and downward taken as negative. This is assumption. So VA is acting up, so it's positive. 4 kilonewton is acting down, we take it as minus 4 kilonewton. And 8 kilonewton acting down again, take it as minus 8. Again here, it's VB acting up, so it's positive again, plus VB equal to 0. Fine. So can I write here VA plus VB equal to 12 kilonewton? Okay. Just transferring from left hand to right hand side. VA plus VB is equal to 12 kilonewton. Now here, our purpose is to find out the value for HB is already find out 0. Unknowns we have to find out. VA and VB you have to find out here. How to find out? Now you go for the third step. First you find out sigma h, then sigma v, then go for moment. That is sigma m. Moment about any point. You can take it about point A or point B, whatever it is. I will go for moment about point A, sigma ma. Now how to write this one? Your moment means force into perpendicular distance. Please keep it in mind. Applied force in anywhere into the consideration is point A here. So force into perpendicular distance. Now for this, you take it this point now here. VA. How to write? Force is VA acting upwards. That is okay. What is acting at point A itself? Same point. So moment distance will be 0. Can you understand? When you take moment in the particular point, any load applied, the distance will be nil. It becomes 0. Right? Then what is then? 4 kilonewton. 4 into this 2 meter distance. Force applied is like this. This 4 here. Distance is 2 meters. Perpendicular distance. That's what. Force moment means force in perpendicular distance. 4 into 2. It is acting clockwise. Right? So it's positive. It's plus 4 into 2. Why I am writing plus here? Clockwise movement is taken as positive, anti-clockwise taken as negative. That we already studied. So 4 into 2. Then again, what do you have? 8. Again plus here. 8 is acting clockwise. Clockwise means to reach point A. Because we are taking momentum of based on point A only. To reach point A, it is 8 into travels a distance of 4 meter plus 2 meter. So 6 meters. Plus it is 8 kilonewton into 6. This is 4 plus 2. Okay? 4 plus 2. 6. Again, what is remaining here? VB. VB is acting anti-clockwise to this A. VB from here, it has to travel anti-clockwise direction. So VB into 2 plus 4 plus 2. That is becomes 8 meter. Minus of VB, minus because anti-clockwise direction, anti-clockwise movement, minus VB into 8 meter. And anything for this HB? Should we write moment for this HB? No, because this HB is a reaction going outward, but it forms in the same line of action, which becomes 0 again. Right? So, plus this all is equal to 0. You need not write, if you want, you can write HB into 0 for your, confirmation or to avoid confusions. So, this is what it is. Now, you solve it, how much you get? I think you will get VA, or this is VA into 0, this becomes 0 here, correct? So this plus, in this is 8, what is this one? 8 into 6, it's 54, right? 54 is this, or 48? 48, right? Then minus VB, 8 VB, minus 8 VB equal to 0. From this you get a VB value. Okay. So whatever, see, the calculation is not important, that you can make it. What is the purpose? How do you take moment here? Moment you are taking, you have to find out what are the reactions possible into perpendicular distance. So you will get an answer for VB here. So after getting this VB value, you substitute this VB in this equation. This is equation number 1, say suppose. So you get VA plus VB is equal to 12 kilonewton from your sigma H and sigma B, you got it. Find VB using your moment, find out the value of VB, substitute here and get the value for your VA, right? So you will get the value of VA, say suppose some 5 kilonewton, VB is some other newton, suppose say 10 or some kilonewtons. That's your answer. Is it okay? So with these values, you have to draw another diagram and indicate the values of VA is equal to, say suppose X Newton, VB is equal to some Y Newton. This value you have to indicate it and show it. And HB, since it is 0, that's a normal product. Okay. When you get a value for HB, suppose, if you get a value for HB, when that HB value becomes negative, you should change this arrow mark. Please don't forget, the arrow mark is considered to be going out of the body, right? This is assumption stating that it will be positive if it is considered out of the body. When the value is negative, you have to reverse the arrow mark and write it. Okay, that's all it is.